maximum one. Okay. So, but here I say I need two data sets. So I will edit the graph here, and here I have this option, add line. I will say WTI price. Okay. So here I have these two variables. Do you see here? The red line is related to the WTI price. It's the crude oil price per barrel. So, for instance, here the price is $72 in December. What about? But look at this. I have data since before 1990, so I need to adjust this. Since 2021, here I have data. Look at this. So, saying that, I will download the data into Excel. Okay, I open this. This is my data. Okay, I have the two variables: the unemployment rate, okay, and the WTI price. But look at this: the WTI price is by days of the week, versus the unemployment rate is monthly data. Do you see here? Monthly data, and this one is daily data. So right now I have a problem. How do I deal with this? Easy, extremely easy. For this, you can select and create pivot table. You say value here. Okay, and then I have this. Actually, what is here? I have this, I have this, and I have this. I don't need the totals, so we can remove the totals. Do you see here? But I don't need the counts. I need value field setting, and I need the average. Okay? But look at this. In some cases, I have these errors. Do you see? It doesn't show data here. If I double click here, the error is because this. Do you see? Are you following me? This is the error. So, what can I do to solve this problem? Because right now, I can match this data. Let me go to this data. This is the unemployment rate. Pivot table here, existing location. I'm going here. Unemployment rate. Termination date. I don't need quarters. Look at this. We don't need a total. Okay. So here I need to match January 2021. Do you see here January 2021 with January 2021? So in other words, January is at this level. So we can remove these columns. Removing this. So this is unemployment rate, and this is the WTI. Do you see here? I match these, and then this with this. But here I don't have data after October. So I have data until October. So I don't need this November, December. So we don't need the grand total. And we don't need November, December. So in this case, this is a good case. So how can I solve this problem? Let's say for February, only one item is creating this problem. Okay, so we're going to the data here, and do you see here what's the problem? NA, we don't have data. However, we have the previous point and the following point before this. So we can create this. The previous plus the following one divided by 2. The average. Does that make sense? So I don't know the middle point, but I know before and after. So what do? I take the average. Does it make sense to you or not? For me, it makes sense. This, usually we call this data imputation. Okay? We are adding new data. Somebody can say, hey, why you don't do this? This plus this plus the following divided by 4. Yeah, you can do that as well. Somebody say, why I don't use the previous one, and that's it. It's okay. This is the art. Okay, this is the art. So I can use this. Usually my preference is this. The previous, following one divided by 2. But you decide. Nobody can tell you that that's not correct. For instance, if you decide to take just the previous, it's okay. Or the previous and after, and then divide by 2, it's okay. Or the last 4 average, it's okay. That's the art. That's not the science part. That's your decision. And that is not wrong, neither correct. Okay? Are you following me? So, saying that, okay, I need to scroll down here. Look at this. Here, I have another point. Another one. I have multiple ones. But doing one by one is extremely painful. Do you see? If I go to the next. So what about if I do this? I create a filter, data, filter, here, remove the numbers, and select this. Look at this, all of them. So I will select this. Here. Actually, is E245. Oops. E245 plus E247. But look at this, 247 is NA. Okay, so I can take 248, enter, do you see? You see what I'm doing here? I'm just pasting the formula. But in this case, I'm taking previous plus, not the following. The following after the first that I know. So in this case, I take the previous 542 plus, I skip 1, skip 2, and I select this. So this is data imputation. Okay, right now I'm gonna remove this, and I have all the numbers. Straightforward. Okay, but here still appear this. How do I remove this? Right click, and refresh. And look at this, all the numbers. So right now, what we're gonna do here is show only one decimal. So right now I have this. What I'm gonna do now is show this. So this is WTI, and this is unemployment rate. Okay, and this is month. But here I would like to merge these two. So I would like to have something like this. Equal 2021 %. Something like this. You see here. And then something like this for 2022. And something like this for 2023. Up to December, but look at this, we don't have November, so we need to remove this, and that's it. So right now, we have this, okay? So right now, I would like to take the logarithm of WTI and the logarithm of unemployment rates. All the numbers are positive, so I don't have any problem. Log this and log this. So right now, what is doing the logarithm here? Look at this. These numbers, the WTI are in dollars, $101. Versus this one, 3.5 units. It's percentage. This is 1 unit, and this is a different unit. So here, we're transforming this data into, first we escalate the data. Right now we have in the logarithm, but this is a percentage, and this is dollars. I would like to see what is happening with this data in certain periods. For instance, I'm going to highlight this. Oops, here is missing date. Don't forget to add. And then I'm going to include this. So insert a new pivot table. And here we have a new pivot table. So we're going to select date here. And we're going to take the logarithm and the this. So our first chart will be a line chart. Okay. So look at this. This is a line chart. And what can we see from this line chart? About the unemployment rate. Do we have high variability in the employment rate? If we move this into the new sheet. Do we have high variability here for the unemployment rate, or is it steady? The same, what, this? I don't see too much variability. What about this? Do you see variability here?
Not too much, but there's more than unemployment rate.
But if you need to report the trend, let's say, look at this. I need to report. look at this. If I insert here, so the trend here is negative. Do you see the trend? And here, the trend, the slope in this section is positive. So, in other words, there is an after and before. Look at this. This is after the slope start decreasing and before the slope finalize the increment. So the slope here start increasing is positive, and the slope here looks like a little bit negative. But what's happening with the crude oil? Sorry, the unemployment rate start decreasing, and what happened here? Almost without slope. Do you see here? This is the big picture, and this is the reason why you are learning these tools. So I'm saying, hey, I split the horizon in two sections. Before 2022 and after June 2022. Before June 2022, the trend of unemployment rate was negative. But the trend, the slope of the WTI was positive. So, looks like the correlation is negative. Why is negative? Because one is increasing and the other one is decreasing. Does it make sense? When I say the correlation, so basically you can say the correlation is negative because one variable goes up and the other one goes down. Negative correlation means that one goes up and the other one goes down. Positive correlation means both goes up. In this case, if you see there, the trend after June 2022 decreased, but the unemployment rate is steady. It doesn't change. It's constant. So the slope is zero. That's the pattern. So you need to provide this kind of comment right down and add this comment here. We are unemployment rate two time periods. Before 2022. Trends. The time series. Before So if you see here, I'm explaining this. What's going on with this chart? What we are showing. Okay. So why we transform into logarithm and we didn't use the real data? Look at this. If I'm going to show, let me insert the original data. Right here, WTI unemployment rate. This is the original one. Okay, I'm gonna insert a new chart. Do you see the difference here? What's going on here? This looks like a flat line. That's a problem. So, and the scale is too high. So that's the reason why we transform the data into logarithm. That's the reason we apply a logarithm here and here. Do you see this orange line is extremely flat? But if we go here, look at this here. Do you see it's easier to understand this? What about before June 2022 in the other one? Look at this here. In this case, everything is constant, before and after, for the orange one. But here, versus here, that everything is constant. Are you following me? Versus here, that here we don't have this pattern, do you see? Let's change the line here. Do you see the difference? Which one do you like? The first or the second? Which approach is better? Which chart do you like? This or this?
The one with the log formula?
The log, okay. But somebody will ask you here, somebody can ask you, hey, what's the meaning of 2 here and meaning of 1? This is not the purpose to understand these numbers. These numbers here, you show the numbers for reference, but the numbers are meaningless. You are trying to capture the shape of your time series. Why is time series? Because it has a date. When you have year, month, or date, it's a time series. You have a sequence of events during different time periods, it's a time series. So, in this case, this y-axis doesn't have any meaning. Somebody asks you, what's the meaning of 0.5? I know that this number is lower than this. It could be a huge number, but when you apply the logarithm, you try to have the same scale to have a comparative analysis. That's the bottom line of the logarithm. And let me tell you something. the logarithm looks like inoffensive. Very, very inoffensive, but it's extremely powerful. I'm going to show you right now. But it's not for this class, but you will learn in the future. Look at this. If you have, let's say, random numbers between 10 and 20, okay? We have the salary per hour. Do you think that in those salaries, is there inequality? In those salaries? Is there inequality? No. What about in column E? Do you think that there is inequality? Somebody's salary is $1,613 versus somebody who earn $10. Is there any inequality? Yeah. Look at this. What they did is something extremely easy. I took the logarithm in C1 of $12. Same thing for each number, we took the logarithm. And then we calculate the variance of this column. And the variance is close to 0. Close to 0 means that there is not inequality. There is not inequality. Versus here, I did the same thing. The variance for each one and the logarithm of each one was we select the variance. And the variance is 1.3. It's close to 1. Close to 1 means inequality. So it doesn't matter which data set you have it. You can measure inequality using this simple technique. It's the variance of the logarithm. Look at it. Here the formula. This is the logarithm. Do you see? I can run this multiple times. Oops. Look at this. I will change this multiple times, and it's consistent. All the time this is close to 0, and all the time this is close to 1. Where can I apply this? Where can I apply these things in real life? Hey professor, where can I apply this? Is just a toy game or for marketing campaigns? You have a pre-marketing campaign and post-marketing campaign. So you will pay, let's say, let me go here. Here is pre. And you have, let's say, random between 10,000. Let's say that this is in thousands, okay? And this is post. Don't forget, it's in thousands. How can I know if I run my marketing campaign, let's say, this is the logarithm. First, I run a marketing campaign. Let's say this is January. So during July, we start the marketing campaign, okay? Let's say 2023. Okay, so this is the revenue in dollars. Okay, so I will calculate here the logarithm of everything, and here I will calculate the variance. So I will fix this, and I drag down this. is the logarithm, and this is the variance. Hey, look at this. I don't have a marketing campaign, but revenues is the same. I don't have a marketing campaign, revenue is the same. There is not a difference between the previous month. Month is same, similar, similar. Hey, look at this. The variance change from 0.01 to 0.66. Something happened. Okay? So the revenue increased. And then I keep doing this, hey. So in this exercise, it's extremely easy to see this review. But what about if you have 2,000 marketing campaigns? 2,000 marketing campaigns. What do you need if you have 2,000? Only this number. That's it. You don't need the full spectrum of number. You need only this, the last one, or the previous or this. That's it. Are you following me? You have 2,000 marketing campaigns. You don't need 2,000 tables like this. The only thing that you need is when was the last month of the marketing campaign and what was the variance. This is close to 1. It behaved better than the marketing campaign. But pay attention to the following detail. Okay? I'm going to create the same scenario. But here, look at this. My variance is equal to 1. I used to sell $1.3 million. Right now it decreased because let's say you hire a new YouTube influencer, and this YouTube influencer create an issue in media, and everybody stop purchasing your item. So here the variance is 1. But in the previous case, the variance was 1. So what's the meaning of this one? Somebody can tell me?
It's kind of just like a measure of change or inequality.
Exactly. There is an inequality. Right now, my next question is, where is the highest weight? Before or after? Because I'm sure that there is an inequality. Something happened after somebody invests money on a marketing campaign. Here, this is the previous one. If you see here, for this case, actually I give this. Okay. Look at this here. What is the highest weight? Pre or post? What is the highest weight in revenue? Post. And this is good for the company. Okay? So the marketing campaign was great. Okay? So what can we do here is just a pre, post, and the average of this, and the average of this. So, who is the winner? The winner is post. Here. What about here in the following one? We'll check here. Who is the winner? 3. So, in other words, I just need this information. Just this information. So, here is the winner. And here is the winner. and you have the marketing campaign name. You have a marketing campaign name here, you have a marketing campaign name. So let's say this is the marketing campaign 2022, and this is the marketing campaign 23. So, in other words, I will have a new spreadsheet with these characteristics. Marketing campaign 2022, 23. Okay? And here, inequality index, or just simple index. And then I go into 2022, I say here this, and then I go into 2023, this, and then here is winner. I start changing this, look at this. How many simulations? Multiple ones. Do you see when I said you need only these lines? I was referring to this. Because the manager will say, okay, I like this, and this is not good.
You can have 2,000 marketing campaigns, and then you filter by these 50% are good, 60% are not good, or 90% are good, and 10% are not good. Simple as that. And you measure performance. All the time you need to measure performance. Okay? So, do you have any question about this? Do you see we're using small data? This is not big data. Small data. If you are going to work with small data, use Excel. Straightforward. Okay? But you need to understand statistics. I don't know if you are taking studying statistics now, but I suggest to study statistics. Try to understand what's the meaning of average, what's the meaning of standard deviation, what's the meaning of the variance, what's the meaning of skewness, what's the meaning of kurtosis. Okay? Try to understand. When you are learning this, usually what I do when I'm learning something new, I call my daughter, she's 8 years old, and I ask her, please listen to me 1 minute. I want to explain you what is a variance. Okay? So I have a set of data, multiple numbers. If the number is extremely high, there is chaos. There is a variability. If the number is very, very small, there is not variability. Okay? So in that way, we explain what's the meaning of a variance. So the same thing with the standard deviation. If you have numbers extremely high, huge numbers, there is noise in your data, high variability. And the question is, do we need high variability in a time series? Let's say in the stock market, let's say we are talking about Bitcoin. Do you enjoy high variability or do you prefer low variability?
Low.
Low. Because high, let's say the Bitcoin is in 20K, and then you have, suddenly you have 50K, that's great. But suddenly you have $1, hey, that's too much. Okay? So you need to pay attention to this kind of variability. The bottom line of this is try to learn statistics, try to learn Python, try to learn databases, try to learn machine learning. And if you have any question, you know my email, and you can send me an email. Hey, I'm learning this. Can you suggest any reference? Happily, I will do it. Okay? So something similar is the final exam. My request will be only this. Okay? Merge the two data sets and create
That's the final exam. Okay? So you can start from now working your final exam when you come next week. You are ready.